level, and we will take you up to differential equations and so on. The idea is not to become a mathematician or solve mathematical problems. Idea is to understand, uh, I would say, the research that goes on where mathematics is used. This is very important, where mathematics is used. So the idea is not to teach you how to solve mathematics like, say, a mechanical engineer or electrical engineer, or even forget about the scientist. But the idea is to explain the concepts and use softwares like MATLAB, uh, especially in this course. Use softwares like MATLAB, which makes your life very simple to solve the problems. So this is the whole idea. So what we will do is we will use MATLAB, or we will have to download MATLAB. Now I will ask Srinivasan to show you how to actually download MATLAB. Now I'll find it difficult to switch between computer, and I'm going to use a pad to write. So that would make it difficult for me to shift one from one to the other. So I'm going to ask Srinivasan, just tell them how to download software. The only thing is that you should have an email address with iitm.ac.in so that it will be free for you. Now Srinivasan will take over the screen and then uh, tell us how to actually download the software and install it. We will not be using it today, so there is no hurry. If you are not able to get it, don't worry about it. You can always approach me at Srinivasan or one in my lab where you can get help to install it. Uh, so I would we will start with um, downloading the software, MATLAB software, and then this today's class is going to be very fundamental stuff, that the stuff that is, or the background that is important to solve the questions which I had given. So don't worry if you already know two of them, three of them are submitted. So it doesn't matter. Just listen to it because the language will be very different. So you will understand the language as we talk. So I would suggest that you don't worry about too much. First of all, don't worry too much about mathematics. We will see how to handle it. Okay. And so I leave it to Srinivasan first to tell you how to actually download the software. Okay, Srinivasan, over to you.
Yes, sir. Uh, I hope my screen is visible to everyone.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, is visible.
Yeah. So we'll have to go to first MathWorks website. MATLAB is a product of MathWorks website. So once we go into MathWorks website, we have to sign in into this MathWorks account. If we don't have account earlier, we have to create it. But just like sir had suggested, kindly keep in mind that we need to create the MathWork ID using the SMail ID that we have got from IIT Madras. So for those of us who have to create an account, just say create one and please enter your SMail ID. MathWorks will be sending you a code which or a link which when we click our accounts get automatically created. We will be asked to create a password for the account, and once that is done, what we can do is we can come back to the MathWorks website and sign in using the email ID. Now my email ID when I was a student was ed14d505@smail.iitm.ac.in. This domain is very important. So we just have to sign in into this. And then for every student ID that MathWorks issues, there will be a particular license number that is assigned to the ID, and the use will be mentioned as academic. What we need to do here is we see the download button over here. We just have to download the software. Please choose the type of system that you are having, either it's whether it's going to be Apple or Linux. I have a Windows laptop with me, so I will be asking to download in Windows. And there are various releases of MATLAB. We can choose any of the release that we want, but it is always better to have the latest release installed in our system, because MATLAB comes with an array of very interesting toolboxes which gets updated from time to time. So it is always good to have a latest version, and MATLAB usually updates the software in a frequency of half yearly duration. So twice every year they update the software, and then all we need to do is we just have to run the exe file that is downloaded. So first MATLAB will be extracting the exe files, and I've already installed in the system, but just for the sake of demonstration, I'm showing it. So we'll just say yes. And then again, we'll be asked to sign in into the installer. We will have to give our email ID, then sign in. And then we will see a variety of packages that are available with MATLAB, and we can choose whichever we want. And depending on that, the size of download will be varying, but the installation will start happening by itself. So just say yes to the terms and conditions, and yeah. So then it will be asking which this is the regular installation procedure that comes with any software. So we'll be asked destination to be uh, downloading and installing the files that are required to run the software. And then once this is done, probably I think so, I won't be able to show more in this computer because MATLAB is already installed in this, but this is the way forward. Just say next, next, and everything will get installed in the computer. Should there be any questions during the installation or something, please feel free to contact us. We will be helping you with installation. Or
Yeah.
if it is still difficult, you can please visit us at IITM. We'll install it for you in your system and give it back. So hope this was clear enough.
I think my suggestion, I'm not going to use MATLAB today because people have to install it, but we will start using it from Wednesday. So I want your computer to be with you so that when I or Srinivasan work out a problem, you can also do it. Um, that is the whole way this course will be run. So if you are not able to download it and install it, uh, please call Srinivasan. I'll share his number. His number is there in the group, uh, and you can get his help. Okay, or call me. It's very simple. The only thing is that you should have iitm.ac.in. That is the condition.
So sending my number in the chat so that it can be noted down.
Okay, fine. So now I'm going to share my screen. So we will. I'll start a new thing. Okay. Uh, let's do some very fundamental mathematics. And the first term which all of us have to learn in
Excuse me,
mathematics.
sir.
Are you able to hear me? Is it okay?
Sir, yes, sir. But sir, is it possible to make it zoom or like make it bigger? The
Because I have to write. This is an iPad, so
okay,
as I
okay.
write, so that's a problem because uh, it's a full screen iPad. Because I can't write it in the computer. I have to write.
Okay,
Right.
okay. Okay, thank you.
Let me check whether I can put it like this. I don't know whether.
This is better, sir. This is better. Much better.
Yeah. So the first or the main concept in order to start mathematics, especially for life sciences, is what is called as a function. Sometimes function is also called as mapping. Okay. So the function is the center or central concept whole of mathematics. Okay. Functions also define, or functions give rise to what are called as models, and and we then play with these functions. Okay. And we actually either develop a function, we will see later, or fit a function to some measurements, or the function is the result of applying very advanced concepts like deep learning or whatever it is. So, center to this whole thing, whether we are doing simple graph, simple things, or you are doing AI/ML, whatever you do, fundamental is a function. Okay, so function, you would have seen this, not that this is the first time you heard about this term function. So, function, that's the symbol we use. You would have seen function f of x. So, and say y is equal to f of x. So, this is ones which you would have seen. Okay. So, you have, if I look at this f of x, you would see that the uh, there is a there are two variables. One is what is called as um, x, the other is what is called as y. So, this x, the value x is a what both x and y are variables, and x we call as an independent variable. So, x is an independent variable. Y, which depends upon the value of x, is what is called as the dependent variable. So, the simple example is just y is equal to 2x. So, if x value is 2, y becomes 4, and so on. So, the functions, we'll see different types of functions. Functions can become complex. So, y is equal to a quadratic form, say 2x squared plus 3x plus 4, can become much more complex as we see different types. It can be an exponential form and so on. So, the first concept we have to notice is that the function takes one variable called x, and that's the symbol we will use to go to y. So, that's why it is called as mapping. Now, later we will see that it need not be just one value of x. Like, it's not, one value. In other words, the function can operate. Now, that's another word which we will use. Operate on more than one variable. So, say x1, x2, and so on. So, up to xn. Understand this: x1, x2, x3, x4, x5. I'm not going to write all that. So, I put just dot dot up to xn. Function can act on all these variables, x1, x2, up to xn, and then give me a variable y. So, it is not that I'm going to operate with only one variable called x. It can be more than one variable. Okay. So, before we go further, two things we have to understand. Okay. So, let us just let's first start with simple things like function of x. So, what is the range of x in which this function works? It can be from minus infinity to plus infinity, or it can be between, say, 5 and 7. So, x takes the value between 5 and 7, this y can be obtained only if the x value takes values between 5 and 7. So, the range of that x is written like this, either an open bracket like this, or it can be closed bracket like this, or it can be like this, and so on. So, if I write 3 comma 5, each one of them have a meaning, or I can write 3 comma 5, or I can write 3 comma 5. So, this x takes the value between 3 and 5. Now, what is the difference between this open bracket and this kind of closed bracket? Open bracket means that 3 and 5 are not included. Suppose I'm going to just put a line. After all, it is x is a line. So, it's a line. Then let's say this is 1, Let's say this is 2, 3, 4, 5. Now, this function acts between 3 and 5. But with one rider, whenever I have a bracket like this, then 3 and 5 are not excluded. That is, in other words, they are excluded. So X, so I say that X acts between, sorry, 3 and 5. So X is between 3 and 5. So in other words, I can go to the value of X being 3.000000001. And I can go, and X can also take a value 4.999999 and so on. But X cannot take the value of 3, nor X can take the value of 5. So sometimes, that is, in other words, we are excluding 3 and 5. Now, if I put a bracket like that, a square bracket, so this is called open interval. So this is called as open. The interval is from 3 to 5. It is called as an open interval because I'm excluding 3 and 5. Now, if I put a bracket like this, are you able to see this? Is it clear?
Yes, sir.
Yeah.
Yes, sir.
So if I now put a square bracket, okay, like, then my X can take the value of 3. So in other words, 3, I'll say, okay, X, 3 is less than, in other words, X is includes 3, X is greater than equal to 3 and less than 5. So in other words, these are what are called as, closed intervals, though it's closed only on one side. In the third thing, I have included 3 and 5 for X. Then X can take a value like that. So after all, you can include 3 and 5, exclude 3 and 5, and whatever you're going to do. So what is our function? I said y is equal to 2x. Is that clear? So X is, the problem is that people get scared by algebra, and let's not worry about it. X is a variable because I don't know X can take the value of 3.1, 3.2, and so on. So I put this X as a variable. So as I said just now, X is a dependent variable, and X is an independent variable, and Y is a dependent variable. Now, the whole world works on functions. You would have heard about a lot about machine learning. Now, if you look at the whole world talks about machine learning. So, what does machine learning to do with functions? In fact, you will be surprised to know that machine learning, for example, convolutional neural network. Don't worry about these terms. Just hear it. Or artificial neural network. So many things. So what does this know? What does this do? It just generates this function. So in other words, under situations where I don't know a mapping, I said mapping is another synonymous to function, then I use this neural network and other things to get a function. So function forms the basis for even things like machine learning. Okay, so that's the first thing we know about So in other words, function is just a relationship between x and y. Okay, so we can say, I mean, we introduce a few terminologies. So how does this, we said x, acts between 3 and 5. We put this as 3 comma 5. Okay, so we have a domain in which actually x works. We call this as domain. And we have, on the other hand, we have what is called as range. So domain B and the range R. So for example, if I now take x is between 3 and 5, which means that I can have one end 3, other end 5, and a number of, infinite number of values between them. I did not say it has to be an integer. Okay, so I said just between x and 5. Sorry, 3 and 5. Now, this function maps these quantities, which is between 3 and 5, maps, okay, between 3 and 5 to values, because it's just 2x. Let's say that function is equal to 2x. That's the function, or y is equal to 2x. So the domain is the values of x, and the range is the value of y. Okay, so here, since it is 2x, I'm going to have values varying from 6 to 10. So this is the range. So the range of this function, which I have defined, operates between 3 and 5, is between 6 and 10. Is that clear? Any questions? Now, sometimes we don't mention the domain because it may be from minus infinity to plus infinity. But sometimes we say that the domain is such that x is not equal to 0. For example, I have a function of x, which is 1 by x. Then when x is equal to 0, this function becomes infinity. So I may say that, hey, it's all fine as long as don't put x equal to 0. Okay, so sometimes we don't even mention it, in which case we call this as a natural domain. Natural domain for 1 by x is one which excludes x is equal to 0. Okay.
Okay, sir.
So many times the function becomes quite involved. So for example, time. Many times we use time as an independent variable. So I can say, for example, the bacterial growth, B, function of B, given by t squared by some 4 plus 1. Okay, so now the bacterial growth, the population size, for example, this is the population size, is now described as t squared by 4 plus 1. Okay, functions are also plotted. We will see how to plot it using MATLAB in the next session. But right now we say that it can be plotted. Now, this is a natural domain for this equation because we always start t is equal to 0 or greater than 0. So this whole thing is t greater than or equal to 0 is domain in which this function is valid. Is that clear? Now, all of us know, say for example, if I give a function like this, so I can say that let's say I would express it like I express y is equal to 2x, b of t. Let me say that I will express it as beta. So that beta is equal to t squared divided by 4 plus 1. Then we know t squared, if you uh, manipulate it, t squared is equal to 4 beta minus 1, and t is equal to root of 4.2, sorry, 4, 2, 4 into beta sorry 4 beta minus 1, so root of 4 into beta minus 1. Okay, so this is the now there are things which we know and we may mistake some things as a function. Now let us say that I'm doing the square root. Let's for a moment say that I want to take the square root of 4. So what is the answer for this? What is the square root of 4?
2. 2.
2. Is it only 2?
Plus or minus 2.
Plus or minus 2. So in other words, a function, it takes the value of 4. Suppose square root is a function. Take a value of 4 and give you plus or minus 2. So it's not a unique value. So this function not 1 to 1. It is not 1 to 1. So it is, in other words, what does this mean? This means that I have my domain, I have a value of 4, and that's the range to which I'm going to go. So if, as usual, I express my function by means of some arrow. So from 4, I can go to plus 2, or I can go to plus 2. So a function, this is, so if I go from x to 2x, that is a 1-to-1 function. So here my function is 1 through many. From one value of 4, I go to plus 2 and minus 2. So I can have another situation where I have my domain and range. I have two values. For example, square function. Then I have two values. Now I'm going to put the other way. This becomes now my domain, and that becomes my range. Then plus and minus 2, both of them, a square function would take me to one value, 4. Whether it is plus 2, I'll get 4, minus 2, I'll get 4. So this is another type where we say many to 1. Now, these functions have, many of these functions have problems in one way. What is that? In order to look at the problem, we have to now define what is called as an inverse function. This is exactly what we did in the previous case, and we will do this for y is equal to 2x. So inverse function is written as f inverse like that. So what does that mean? Given x, I can get y. So I can ask the question, given y, can you get x? Yes. So x is equal to y divided by 2. So that becomes an inverse function. This kind of one to many and so on will have trouble in getting you an inverse function because I can't get a unique value. So for the time being, we will say that one-to-one functions are the ones where we can we'll put some restrictions later, but we'll say that they are the ones which are amenable for inverse functions. These functions are the ones we plotted as a graph. Say, if I say that function x versus y, I can plot it and give various names to it. So the both of them are in the graphs. What you see here, x and y are related by a straight line. So then, I mean, we'll see about the slope and so on, maybe a bit later. But you would notice that this is just a straight line, and it is called as a linear. It's a linear function. Yeah. Now, when you plot this kind of graph, you will be interested, or it will be interesting to note that one-to-one would be a problem when you plot it like that. Suppose I have a function, a complex function, 0.6, say x cubed. It's a cubic function, as you would call it, squared minus x plus 4. If I now plot it, so it's like that. Then you would, it can go like this and so on. Then you can immediately see that for a given, this is y, this is x. So for a given y, I have 1, 2, 3 x's. So x1, x1, x2, x3, all of them give you the same y. So if you, when you plot it, you would notice. So the plotting, I'm sure all of you know. I'm not going to explain what they are, but we will get into plotting. We have to plot MATLAB in the next class. Now we also give names to these functions. As I said, linear function. I can say a is equal to 3x squared plus 4x plus 5. Quadratic function. Here is x cubed, so we say cubic function, and so on. So we generally write this as a x power n plus a1 x power n plus a2 x power n minus 1 plus a naught. Sometimes you write this also as other way, a naught plus a1 x squared, so on, an. Sorry. Yeah, a plus an. So there are various ways of writing it, but nevertheless, this is more common. This is because there is some problem with that. So this is more common to write a naught plus a1 x squared plus a2 x cubed, so on, up to a1 or an. Or sometimes this is written as b. Okay. No, I think that's not required because I had put a naught already. So a naught plus a1 x squared plus a plus a2. Sorry. So a naught plus a1x plus a2x squared plus a3x cubed plus and so on. I wanted to explain something else. I jumped. Plus a power an x power an x power. So I can write it something like this. Where every term here is present. So you can see, actually this is x power 0. So x power 0 is 1. So x power 0, x squared, x cubed, and so on, up to x power n, say for example. Then we say that this whole, this is called polynomial, and I am not leaving out any term. Then I call this as complete polynomial. It's complete, nothing I'm going to do. So you can use other symbols to express y. So y can be expressed, for example, a naught plus put one sigma and then say ai x power I is equal to 1. So let me do that here. Y is equal to a naught plus sigma I is equal to 1 to n ai x power I. So if you really look at this, it will become a naught. Sigma is just a summation symbol. So this would become, first I put I is equal to 1. This simply means that I is equal to 1, where I varies from 1 to n. So if I now expand it, this will become a1 for I is equal to 1, x power 1, which is x, plus a2 when I is equal to 2, takes the value of 2, x squared, plus I takes the value of 3, x cubed, and so on. So that is a polynomial. Now, the problem is in many situations, you do not know this function. Function becomes very complex. The functions become very complex because we may not be using nice functions and nice variables like x, y, and so on. So I don't know the function. In one situation, I've written down the function for you, and I'm asking you, given the value of x, tell me y. That's the simplest of all cases. I know the function. But many times, I don't know this function. Functions, I don't even know the form. How does it look? Okay. So under those conditions is where things like machine learning, convolutional network, all those things come. So now, this variable, what we had looked at, variable called x, can be a continuous variable or a discrete variable. So when I say x defined between 3 and 5, then it's a continuous variable. Sometimes it will not be continuous, but will be discrete. We'll come to that more. So it can be a discrete variable. So at that time, I will operate not as a x as a continuous x is 3.11111 or 3.00001 so on, but with specific values of x, discrete values of x, which I would define as x1, x2, x3, and so on. This can be, say, 3, 3.05, 3.1, 3.15, so on. So I will operate with the discrete values. Okay, any questions? No questions? So clear?
So, so
Can
when you said, when you talked about the natural domain, uh, is it only natural numbers or everything except
No,
zero?
no. Natural domain is, we know at x is equal to 0, it will, uh, you know, it will go to infinity. So wherever it's not defined, we call this as a natural domain. Now, you brought in a very interesting point. So x, I'm going to write this x. Another symbol I'm going to introduce x. When I put like this symbol, member of R, which means that all x takes the values of real numbers. That's R. Okay. Now, suppose I have a graph, right? So in a graph, x, let's say this coordinate point. Okay. In the coordinate point, I will have, say, for example, the value of x is the value of y. So this is in 2 dimensions. All of us are familiar. But sometimes I may have to increase the dimension. For example, I will have like this. So this will be, say, z. This will be x1. This will be x2. So I hope you understand that it's in 3 dimensions: x1, x2, and z. So I will say z, the function of x1, comma x2. But I'm always seen in mathematics, people are lazy to write. So I'll say, I don't want to say x1 and x2. I will write this as f in textbooks with bold letter of x or an underscoring. Then I would say that underscore is actually 2 values. So this x is 2 values, x1 and x2. In which case I would say x is a member of real space R2. X can be a member of Rn and so on. So the domain of x can be a real number, only one number, can be 2 numbers, can be n numbers. Right? Similarly, the left-hand side is z, we call it as y, and so on, can also be more than one number. Can be y1, y2, up to ym. Okay, in the left-hand side. The right-hand side, x1, x2, so on. So then connecting the up the xn, connecting this left-hand side to right-hand side is a special function which we will see later. Okay, which we would call as a matrix, and we see later. So now we know what is quadratic function, what is cubic function, what's a square root function. Okay, and you can take cube root, for example, cube root. So you can know cube root function. Okay, so we also introduce what is called an absolute value function, which we will use quite often. Which, say, for x is written with this symbol. So function x is equal to x. And then we write this function like this, is equal to x if x is greater than equal to 0. Note this carefully, minus x if x is less than equal to 0. Now look at this carefully. So if I say it is an absolute value, if I say, yeah.
Uh, just a small clarification. This R power n is a dimension or the number of elements you are referring to?
That is the dimension, which is also the number of elements. Yeah. So x1, x2 up to xn. Okay. So like x1, x2, up to xn. So it's the dimension of the space, the dimension of my domain. So here we had x1 and x2. Okay, that is the two dimensions, x1 and x2. Okay, so now x belongs to x1, uh, belongs to R2, means that there are two values of x, which is x1 and x2, which occupies the whole real space. Okay, so that is the dimension. So n means there are n dimensions.
So just to add a small clarification, can we say that, hello?
Yeah, please go ahead.
So x1 can have a set of values, x2 can have a set of values, because people might confuse that x1 is a single value.
No. X1. See, the variables you have been so far using only x, y, z, and so on. From now on, please understand that variables can also be denoted as independent variable. For example, this matter as x1, x2, x3, xn, and so on. So there is a subscript. Good point you brought up. So it's a subscript is or can also be used in order to define a variable. So x1, x2, x3, x4 are all independent variables. Please note this, independent variables, which means that if I now go along this line of x1, so x1 can take a value of 3, 4, 5, and so on. If I go along this line, x2 can take a value of 3, 4, 5. So in this region, x1 and x2 can take values between 0 or minus infinity to plus infinity. So this is some. This is, let me. All right. So x1, x2. So I take this point. This point may be 3, 4. Okay. Now 3, 4. So that is the. You understand? So 3, 4 is a point is in that region. So I can as well put, I can go minus x2 minus x1, which means that I can cover the entire range. So x1 and x2 are two variables which can take values from minus infinity to plus infinity. So I would write in my old language minus infinity. So x1 can take values between these two, and x2 can take again values between minus infinity. Is that clear?
Yes, sir.
Hello?
Yes.
Yeah. So, Pratibha, does that good point?
Okay.
Any questions? Okay. So now if you look at this function, so if you take value of x is equal to minus 3, so x is minus 3, then the second part of this function operates. So minus 3, if I put here, then actually becomes 3, because minus of minus into minus becomes plus, so it becomes plus 3. So in other words, this is how mathematically you define the function. It's a actually very interesting function. There are a lot of interesting issues with it. Mathematically, it becomes a very interesting function. But, okay, it just tells in pure English, take the absolute value. Absolute value of minus 3 is 3. Take the absolute value.
Then there won't be any minus at all, sir.
Minus at all. In this function, if I define it like this, there won't be any minus at all. Okay, this is called absolute value of the function. Now, the function need not be one thing. The function can vary, okay, from one region to another region. So, say I can define y is equal to 2x plus 1, okay, if x is less than 1, or define 2x minus 1 if x is greater than equal to. So, or some other, y, say 3x if x is greater than equal to 1. So, depending upon the kind of domains, I can change the domain and define a function like this. So, that can be piecewise, discrete functions. There are, it can have different, can be a different function uh, based on the domain. So it's a piecewise function. One piece is this, other piece. Clear? Any questions? Many times, as someone asked Jason, I think someone asked the question, what is this domain, natural domain to function? So it comes out the function as it is. Say, for example, I have a function 1 by dot. Now, when x is equal to 5, I know. X is equal to 6, I know. Okay. Now, from 4 onwards, I have trouble. Okay. Now, when that is minus 4. So, if I make this x plus 4 to be less than 0, less than equal to 0, then I have a problem. Even taking into account the fact that 1 by 0 is infinity, understanding that, I would say that x plus 4 has to be greater than or. So, in other words, if x is equal to minus 6, what would happen to this root of minus 2? As of now, we have not defined what is the square root of a negative number. We have introduced. So, for the time being, we do not even know how to calculate. So, when we are now dealing with what is called as real numbers, the natural domain of this function does not include values which will make that square root to be negative. If I extend my understanding and say that the function of x can also take complex numbers, which we will not introduce now, we will introduce it later, then I don't care. Clear?
Yes, sir.
Okay.
Yes.
Right. So sometimes what we do is we do elementary operations with functions itself. So I have two functions. Let me call that as f and g. So f of x f of x and g of x. So we use notations called summation. So for example, this can be 2x. Y is equal to 2x. So then I can sum a function. So in which case I define this as f plus g x is f of x plus g of x. Okay. Similarly, I can find out the difference of these functions by saying f of x minus. We also have what is called as a product of the function f dot g, which means that f dot g gets f of x multiplied by g of x, in which case our function now becomes 2, 3, 6 x squared. Is that clear? So sometimes, I mean, lastly, we can also use f by g x. When we write like this, what it means, f of x divided by g. Okay. Now we come to what we call as composite function, which we would use the term. Note this carefully. This is slightly different. On small circle, okay, f of g. So what does this mean? It means that if I now have this domain x, okay, then I can use a function go from x to say y. So gx is the function I use. Y. Then I can use on y another function which I would define as f in order to go to z. So I am going from x to z by using two functions, f and g. So in other words, it's a composite function. What I do is first I operate on x using the function g. Then on that result, which happens to be y, I operate another function, f. So f of x, which is written as f. So g is the inner because it's inside. It's called as an inner function, and f is an outer function. Okay, so in order to understand this, let's say that I have two functions, f of x. Look at this f of x is 4 plus x minus x squared, let's say, and g of x 2 of x, 2x. Now let's say calculate composite function fg at, I'll give you 2 minutes. Let's see, calculate this. So I have to calculate f g of x. Now x is equal to 2, so f g. So what is it? Anyone? So x take the value 2. Takes the value 2. Yeah.
16.
Is it 16?
8.
8.
-8.
Negative 8. Okay, let's do it. So what does this mean? So this means that f of g of x This is what we mean. So in other words, I have to first perform g of x. So what is the result of g of 2? That is equal to, if I substitute x is equal to 2 here, I'll get g of 2 equal to 4. So now with this, I have to put f of 4. That's what here is. But what is f of 4? I have to substitute it in this expression 4. So 4 plus 4 minus 4 squared. So this means that it is 8 minus 16. Is that clear? So that's how you composite functions calculate. Note this. Now let us say, let's put the other way. Now you calculate. Now that you know how to calculate it, what is this value? Hello? Yeah?
Plus 8.
Plus 8. So first is f of 2. What is that function? 4 plus x minus x squared. Four plus x minus x squared. So what is that? F of 2. So how do I write this? G of f of 2. So what's f of 2?
8.
4 plus 2 minus 4.
6 minus 16, 10.
No, 4 plus 2 minus x squared is 2. 2.
2.
Oh, 2, yeah. Oh, right, yeah.
Okay. So g of 2. What is g of 2?
2x, 2, 4.
4.
So note this carefully, that when I had put like this, first I did this g and then f. In this case, I did f first and then g. In other words, the inner function is f here, the inner function is g. And I change the inner and the outer function. The results are different. So we write that f is not equal to g. Is that clear?
Yes.
Yes, sir.
Okay. So let us, in order to give you some, idea, let us say that we have, uh, we have a bacteria, a population of a bacteria. Let's call this as rho of B. Bacteria population, or we will say density, because it's rho, call this as optical density. And B, the variable, okay, for this function, B becomes the independent variable. See that it may not be the case, is the bacterial population size. So that is the clear. Now let us say that B itself is a function of P. So in other words, bacterial size, the size, what does it mean? Size changes. So in our language, G of x, what we had put. Now, actually, in our language, it is now p of t. So g of x and p of t are similar, same. So what is f now of x? Actually, rho of b. So p becomes t. So if I now plot that three curves, three regions, domain. So I start, this is the time. This is the domain for time. Then I have one function from time, okay, which is called as b of t, which takes me to the population size. Then I have another function, which is rho of b, which takes me to optical density. So I have a quite a complex thing, but anyway, composite functions, where I move from time to first domain, from first domain to this range here, and then from there I move to the. So this is what we called initially. This is what we called as. Let me see, colors. So this was what we called as x. Then we said g. So this becomes y. Then we said f, and that becomes z. So in reality, g of x, f of x is now, say, for example, b of t, rho of b. So t, now x takes the values of time, y takes the values of population size, z takes the value of density. So this is how we generalized it, calling it gx and f. Then now, a specific example, called them as b of t and rho of b. Is that clear? So we are going in for a complex function. Is there any questions? Or composite functions? I mean, English word complex, so it becomes a composite function. Right. So if I have a function, say, let us say y is equal to function of x. I told you before that x can be determined by an inverse function. So this is what we said, y is equal to 2x, then x is equal to y by 2. So that becomes the inverse function. Going from one to the other, inverse takes us back. So for example, I went from a to b by using a function f, then I come from b to a by using a function. Is that clear?
Yes, sir.
Yeah. So now let's see what are the functions that can have an inverse. They can't have an inverse. Okay. Now let's say that I have a function just like this. If I draw a graph, okay, it's a quadrant. Y is equal to x squared.
Excuse me, sir.
Yeah.
Sir, can you also provide an insight like why do you say quadratic, cubic? So they will be familiar with those
No,
terms.
that I have already said that here, that when somewhere. So I said that when I keep raising the power of x from linear, 3 I said cubic, 2 is quadratic, x power 4 is what is called quartic, and in general we call this all of them as a polynomial function. Okay, so that's what we wrote. So depending upon the power of x, we can keep quadratic functions. You would have seen quadratic functions, solution for quadratic functions, and so on. So that is the, so it can be, depending upon the power of x, it can be quadratic, cubic, 3 means cubic, and so on. So I have a function like this. I have a more complex function. I may not write that here. So this is y. Y, say, let's say x. Let's say that the function is something like that. Then I have a function which is like this. Okay, let me call that function as some g of x. Let me call that function as f of x. Let's say that's squared. Now, these functions is x squared, some function of x. I want to know whether they have an inverse or not. We had already seen this. Okay. How do I find out whether they have an inverse or not? So how do I find this out? I want to know whether they are one to one, okay, or one to many, or many to one, and so on. Okay. So of all these three, which means that I want to know why am I saying this? Let's understand this. Let's take this graph and draw a straight line. Okay. So I have, as I told you before, x1, x2, and x3. There are three values of x, okay, for which I get the same value of y. Let me pictorially draw. Let us say that is the domain. What is the domain here? X, the domain. And range. What is the range here? Range is y. Now, what does it mean? This graph about x1, there are three values of x: x1, x2, x3, and I have one value of y. So x1 goes to y, x2 goes to y, x3 goes to y. So these are three different values of x. Now you should understand that. So please don't confuse between x1 being a variable. No, x is the variable. It takes specific values of x1, x2, x3. Get used to it. If you want more clarity, x1 can be -2, x2 can be 1, and x3 can be 5. So have that clarity. Sometimes I will call x1, x2, x3 as a variable itself, x1 as a variable itself. Sometimes I would say that a specific value of x is x1, a specific value of x is x2, specific value of x is x. That is what the distinction comes from the particular application. Now there is only one value of x. I'm talking about function between, look at that, x and y. So now under these circumstances, when I put x1, x2, x3, then I have three different values of x. This is -2, this is -2, +1. Okay, so three values means that, again, let me clarify. This x1 is -2, 1, and 5. So -2, 1, and 5, they take us to a particular value of y. Let us say that that value is 3. So they all take me to 3. That's fine. Many to 1. But when I want to come back, okay, and I have the value of 3, let me see what happens. I have value this. Now I'm coming from y back to x. So from the value of 3, I have to go to 3 values: x1, x2, x3. I can go to, from 3 I can go to x1, or from 3 I can go to x2, or 3 I can go to x3. Because all the 3 values of x1, x2, x3, which is -1, what is the value? -1, sorry, -2, 1, and 5. All these 3 values, to 1 and 5, all the 3 values took me to 3. So when I come back from y to x, one value of y can take me to any of the 3 values. In other words, it is not unique. I don't know whether the function has to take me from 3 to 1, or 3 to -2, or 3 to 5. So one to many, this kind of thing does not, a function doesn't exist. So I would say that it has no inverse. That's the same case here as well. In this case, fortunately for us, it is only 1 to 1. So we can have an inverse for this function. So if you understand the concept of 1 to 1, 1 to many, you will understand the concept of yes.
So I didn't understand why one to many don't exist.
1 to many. So suppose I give you a value of 3. Okay.
Yes. Yeah.
Let us say x is equal to 3. Okay.
Yeah.
I want a function y. Okay. I want a function which will take me to y. In other words, this is what I want. Right. So it is, please note that what we are looking at is a deterministic function. So if I plug in a value of 3, okay, I should be clear that it should take me to, or 1, or whatever it is. One value. So if I put 3, it has to take me to, say, 6. But if I put 3, in this case, say if I put 3, it may take me to -2, it may take me to 1, or it may take me to 5. All 3 are correct answers.
Yes.
So I don't know, then how do I write a function? I can't write the function.
Yeah.
So this kind of thing is not valid.
Okay.
Understood?
Maybe, sir, could we say that in random experiments we can have one to many functions?
No. So
Rolling
one,
a dice.
no. Wait. That's why I said deterministic. So when we go to probability, a probabilistic function, then it is a different type of function. So I use the word deterministic function. It is deterministic. It is one value. So when I now go to a probabilistic function, then I can put a probability. There's a if you go to 3, there is a 20% probability that it is -2, this function. It is 50% probability that it is 1, or 30% probability that it is 5. Then we are going to probabilistic function. We are not there at all now. We are only in the deterministic function. So you have to distinguish between deterministic function versus probabilistic function. We are not here. So we are looking at deterministic function. Clear?
Yes.
So we can say function of x, y is what we say. So then f inverse of y okay. So now I can have a composite function of f inverse of y. What will be the answer?
It's y.
Y.
Yeah. Y.
Right. So f
Yes,
inverse
sir.
of y is equal to x, f of x is equal to y. So I get back this answer as y.
Y.
Clear? Any questions?
But if one of those inverse function is invalid, then would this stand?
So we won't deal with invalid functions
Okay.
in this class.
Okay.
Okay, so don't worry. Right?
Yes, sir.
Okay. So we have learned a lot about functions. There are other functions which make our life miserable. Okay. Those are periodic functions. Okay. There are other types of functions. Maybe, I think we'll stop here before we go to other types of functions, which are called as rational functions. Maybe I'll finish with this. Rational functions. Suppose I have a function which is, say, 2x cubed minus 4 divided by x plus 3. I have a function like this. So there are two what we call as polynomials. Of course, different powers are there. Then we call this one as a numerator and another in the denominator. This is the numerator and another is the denominator. Then we call this a rational function. Yeah, we call this as a rational function. So we also have trigonometric functions, which are called as transcendental functions. We'll not do it now, we'll do that in the which involves sine, cos, and sine inverse, and so inverse trigonometric and trigonometric functions, exponentials, so on. We'll see that in the next class. I think we'll stop here, and if there are any questions, I'll take questions. This is recorded, so Srinivasan is in charge, so you can get these. Any questions?
Do you recommend any books, sir, for this basic thing?
Yeah, I'm not going to follow a single book, but there are. Let me check. I'm just taking from here and there and just
Okay, sir.
putting it. So this
Yes.
notes what I am going to write, that would be a very good thing. Apart from
Yes.
the questions which I'm going to give. So the notes will be a good book because there's no one book which I can look at. I'll keep
Okay.
Okay. Yeah.
Okay, sir.
Thank you. I hope you were with me for the past 1.5 hours. Don't worry, if you want, you can listen to it again. And
If you have any doubt, can we come to the lab and ask?
yeah, of course, anytime.
Yes.
Okay. Thank you, sir. Thank you, Dr. Vijay
Thank you,
Kumar.
sir.
See you there.
Thank you.
Thank you.
Thank you, sir.
Thank you,
Thank you,
everyone.
everyone. The recording link will
Thank
be
you, sir.
shared tomorrow. the daytime.
Sure.
Thank you.
Yeah.
Thank you, sir. Thank you, sir.
Okay. Thank you. Bye.
Thank you.
Bye, sir.
We'll meet on Wednesday.
Thank you, sir.
Thank you very much.